Hello, everyone. Someone had some more questions on the Unit 3 summative assessment. They wanted to know have some help with numbers 6 through 12. So we're going to do some examples that will help you guys out with those. All right, so quadratic functions. Now the first thing is what makes a function or an equation a quadratic is you have an x squared in it. Each one of these functions and equations, there's an x squared in it. Now notice when it's a function, it's going to be y equals or f of x equals. Remember, y and f of x are pretty much the same thing. In an equation, you're going to replace those y's and f of x's with 0, and you're going to be solving for x. Okay, so remember, in the equations, the functions we just looked at, they all had an x squared in it. They all had an x in it, and they all had a constant. Now, what goes in front of, let me change my colors here for this part. All right. So whatever is in front of the x squared, we're going to call that a. Whatever's in front of x, we're going to call that b. Whatever the constant is, the number without the variable, we're going to call that c. Now, if we were doing what's called the quadratic formula to help us solve quadratic equations, this would be very, very helpful. So, in the equation on the left, okay, so we want to say what is A, what is B, and what is C. Well, A is whatever's in front of x squared. So A is 9. B is whatever's in front of x. And C is whatever the constant is, -8. Over here, instead of having y equals, we have f of x equals. Same concept. We're going to figure out what A, B, and C are. A is not 3, even if it comes first. What's in front of x squared? -7. So A is -7. B is what's in front of x. So it's going to be 3. And C is going to be the constant, the 18. Now, if we were solving these equations, assume there was a 0 here or there was a 0 here, we could use the quadratic formula, plug in A, B, and C, and we would solve. That is going to be left for Algebra 2, unfortunately, for the way our school year has gone. All right, so now we're going to start solving these quadratics. We are going to be talking about their graphs. And now what I want you guys to see here is that you can call something a root or a 0 or a solution or an x-intercept. And they're all names for the same thing, different names for the same thing. So if we go to this equation here, change my color over here. All right, so here's our equation, our function, been graphed over here. You can call them roots, zeros, or solutions. You can call them x-intercepts. It's all the same thing. So let's come over here. Let's see where our curve hits the x-axis. Looks like right here. Let's see where our curve hits the x-axis. Again, about right here. That one looks like it hits around at 2. 1, 2, 3. This hits at around -3. So your roots are, oh, got to change the color. Can't see that. Okay, so the roots are going to be -3 and 2. The zeros are, you guessed it, -3 and 2. Now what that means is if I replace this x and this x with -3, and I did the math here. Well, let's go ahead and circle it. If I plugged in -3 for these x's, and I did the math here, I would get 0. If I plugged in 2 here and here, and I did the math, I would get 0. Right? And solutions, that's when the equation is actually equal to 0. And of course, we just figured out those two numbers make it equal to 0. Your solutions are going to be -3 and 2. Now notice I don't put parentheses around those, otherwise it looks like an ordered pair rather than listing two separate answers. All right, let's go to the next one. All right, so what are the zeros of this function? Well, let's see where it hits the x-axis. Here's my x-axis. Looks like it's going to hit right here and right here. So the zeros are at -2 and 1. That's it. Zeros, x-intercepts, solutions, roots. Where does the graph cross the x-axis? Basically, you're looking for the x-intercept. All right, moving along. Now we want to write equations of these. All right, so first thing is, where does this hit the x-axis? Looks like it hits right here. 1, 2, 3, -3, and over here hits at -1. So our roots, or our solutions, or our zeros, whichever term you want to use, I'm going to use roots this time. Our roots are at -3 and -1. So now remember that the equation for these things, let's see if I can find a slide with one in it. Let's go back one more. Remember the equations for these were something x squared, x minus 8, something x squared, an x term, and 18. And we want to get to that point, but we first have to put it in what's called factored form. Sorry about my slow writing. So we first want factored form. Factored form is going to be x plus or minus something times x plus or minus something. Now, for your somethings, you look at your roots. That's a -3. Take the opposite, plus 3. The other root is -1. Take the opposite, plus 1. Now we want to put this in standard form. And we're going to use one of the last things we learn in class. Basically, we're going to distribute twice. All right, so x times x times 1, 3 times x, and 3 times 1. So our equation of this curve in factored form, it's going to be y equals, we've got x squared over here. We're going to combine the 1x and the 3x. And then we got a plus 3 tacked on the end. Okay. Now, ooh, let's try that again. Now we have the equation of this quadratic. Again, has an x squared in it, so you know it's going to be the shape. It's going to be a quadratic. And I believe I have one more example for you guys. Okay, so we want to write the equation of this one. So, how do we begin? All right, we want to find the roots or the zeros. It's the x-axis here, the x-axis here. I called them roots last time. I'm going to call them zeros this time. Okay, so the zeros are at, that looks like that's at -4, and this one looks like it's at 2. So we're going to have x plus or minus something times x plus or minus something. All right, one of my zeros is -4, so I put the opposite, +4. The other zero is 2, so I put -2. Then we multiply it back together. So we're going to have y equals, because it's the equation of the quadratic, and then x times x times -2. We got to keep that sign in front of it. So -2x, 4 times x, and then 4 times -2, -8. And we just clean it up. X squared, -2x plus 4x plus 2x minus 8. And then I think one of the questions just gives you the roots of the zeros. It doesn't give you the graph at all, which makes it even easier. But I want to do one example like that. So let's say that the roots are -5 and 6. All right, so y equals x plus or minus something, x plus or minus something. One of the roots is -5, so the opposite, +5. One of the roots is 6, do the opposite, -6. Now we just have to distribute, multiply it together. So y equals x times x. Again, I'm just distributing. X times -6. 5 times x. And 5 times -6. And then for our final answer, y equals x squared, -6x plus 5x is -1x. You're welcome to put the 1 there if you want to, minus 30. Hope that helps you guys with the quadratic section.